Get ready to dive into 10 mind-blowing black hole curiosities. Number 1. The point of no return is a sphere, not a wall. The event horizon is the boundary where the escape velocity equals the speed of light. It's not a solid surface, but an invisible sphere. Once something crosses it, it's trapped forever, even light. This sets the stage for the ultimate cosmic prison. Number 2. Spaghettification, the gravitational noodle. If you fell into a small, stellar mass black hole feet first, the extreme difference in gravity between your feet and your head would stretch you out like a piece of pasta before you even reach the event horizon. This gruesome yet fascinating effect is called spaghettification, or the noodle effect. 3. Black holes eventually evaporate, very slowly. Thanks to physicist Stephen Hawking, we know black holes aren't perfectly black. They emit Hawking radiation, which causes them to slowly lose mass and energy over time. Tiny black holes would evaporate almost instantly, but the largest ones could take 100 years, far longer than the current age of the universe. Number 4. They come in multiple sizes. There are at least 4 proposed types: stellar mass, 3 to dozens of times the sun's mass; intermediate mass, hundreds to thousands of solar masses; supermassive, millions to billions of solar masses; primordial, hypothetical, microscopic black holes formed in the early universe. Number 5. A black hole could fit in your pocket. If you could compress the mass of the sun down to about 6 kilometers, 3.7 miles in diameter, it would become a stellar mass black hole. If you could compress Earth down to the size of a marble, it would become a black hole. This highlights their incredible density. If you could compress the mass of the sun down to about 6 kilometers, 3.7 miles in diameter, it would become a stellar mass black hole. If you could compress Earth down to the size of a marble, it would become a black hole. This highlights their incredible density. Or 6. They don't suck everything in. Black holes only pull things in if they pass too close. If the sun suddenly became a black hole, Earth's orbit wouldn't change at all. We'd just be orbiting a dark 6-kilometer mass instead of a bright star. Their gravity acts like any other mass. They just have a much smaller area of guaranteed capture. There are millions of them in our galaxy. Astronomers estimate there are millions of stellar mass black holes in the Milky Way alone, but most are invisible because they aren't actively consuming matter or tugging on nearby stars. They are essentially rogue dark spheres silently orbiting the galactic center. Number 8. Supermassive black holes power galaxies. A supermassive black hole, SMBH, resides at the center of almost every large galaxy, including our own, Sagittarius A. When they are actively feeding, the disk of gas and dust spiraling into them becomes superheated, emitting brilliant light and powerful particle jets. These active SMBHs are called quasars or blazars and can outshine the entire host galaxy. Number 9. The no-hair theorem. The no-hair theorem states that once matter falls into a black hole, all you can measure about it are 3 properties: its mass, its electric charge, and its angular momentum, spin. Everything else, what the matter was made of, its shape, etc., is lost forever. A black hole is mathematically incredibly simple. Number 10. Time bends. Near a black hole, according to Einstein's theory of general relativity, extreme gravity slows down time. An observer watching someone fall toward a black hole would see the falling person's time slow down dramatically as they approach the event horizon, seemingly freezing just before crossing it. Conversely, to the person falling, time outside appears to speed up. Which curiosity blew your mind the most? Let me know in the comments.